This is Dr. Dave Nguyen. Welcome to part 3 of my series on what is randomness. In this video, we'll talk about pseudo-randomness, periodicity, and sufficient iteration. Pseudo-randomness is a very important concept in computational sciences. Pseudo means fake or not real. Therefore, pseudo-randomness means not really random. Pseudo-randomness began when a physicist named John von Neumann created the first Pseudo Random Number Generator, PRNG. And his method was called the middle square method. He needed a way to generate a series of numbers that were randomly picked, right, so that he could do his research, but he needed this randomly picked number to be reproducible by his colleagues. Therefore, he created a method to do such a thing. So for his method, he started with what's called a seed number. In this case, for example, it's 1, 2, and 3, 123. If you square 123, you get 15,129. Then if you take the middle, numbers, which is 5, 1, and 2, you turn that into the seed for the next round. And if you square 512, you get 262,144. And then if you take the middle four numbers and turn that into the seed for the next round, you square it, and so on and so forth. And what you get is a series of numbers, right, that are generated as a pseudo-random sequence. Now, nowadays, we have very sophisticated pseudo-random number generators, way more complicated than the middle square method. But we all teach about this because it is the original method and quite clever. So no matter what, how powerful a pseudo-random number generator is, ultimately that sequence of numbers is not truly random for several reasons. One is because pseudo-random number generators produce sequences of numbers that are 100% repeatable, right? Given that you start with the same initial seed. In our case, previously, it was the number 1, 2, 3. Secondly, pseudo-random number generators have what's called a periodicity, meaning if you let it run enough times, eventually it will give you the original number that you started, the original seed, okay? And therefore, once you reach the original seed, all numbers after that will be a repeat of the numbers that came that you already generated, right? And thus, there's something called a period or a point of repeat, right? A pseudo-random number generator will give you a string of random numbers up until it hits the original seed, and then it starts over again. And so the fact that there is a structure that is a periodicity to pseudo-random numbers, right, and pseudo-random numbers are repeatable given the initial seed, therefore there is a predictive nature to pseudo-random numbers, and this predictive nature means that it's not truly random. So why is it important to understand pseudo-randomness? Well, every scientific model, simulation, or test that uses pseudo-random numbers is only as accurate as its assumption of randomness, okay? And if you try to solve a problem by creating a simpler model of that problem, you need to understand that the model may be giving you misleading answers because of the pseudo-random process that you picked. In fact, this pseudo-random numbers is one of those potential sources of confusion when two different researchers study the same thing but get slightly different results, right? Their choice of their pseudo-random number generator might be one of those causes. A funny story, I once had a student who was getting A's in his language class, but he was losing participation points. And so even though he got A's on everything, quizzes and tests and homework, his grade was still a B in the class. And I asked him, well, why didn't you participate? He said, I want to, but I can't because the teacher, right, picks students based on a random number generator on his desk. And so if he doesn't, call your number, then you can't participate. And I said, wow, and so I asked them, okay, well, is it in your experience that he calls on his number generator, calls on certain groups in the class, certain seats more than others? And the student says, yeah, how'd you know that? I then explained to the student what a pseudo-random number generator is and how periodicity can actually skew that result. And so this was very eye-opening for the student. And it became clear to the student that just because the teacher was using an unintentional process to call on students, it doesn't mean that that process was fair, even though the teacher thought it was fair. And the fault wasn't the teacher's, unintentionality in biasing who to call on, but that he didn't fully understand the pseudo-random number generator that he was using to decide who to pick. Ouch.